Welcome to The Explainer. Today, we're jumping into one of the biggest, slipperiest concepts out there, time. I mean, we all feel it, right? We live our lives by it. But what is it really? Is it some fundamental river flowing in just one direction? Or maybe is it just a stubborn illusion our brains create?
The philosopher St. Augustine, way back when, just nailed it with this. Time feels completely obvious, right up until you try to explain it. Then it just sort of slips through your fingers. Well, today, we're going to try and grab onto it by unpacking a fascinating theory that really challenges everything we think we know.
So, where do we even begin? Let's start with physics. For decades, scientists have been wrestling with this one particular puzzle. Why does time seem to move in only one direction?
Okay, so the standard view in physics is kind of startling. When you get down to the most fundamental level, the laws that describe our universe, they don't really care about past or future. The math works perfectly fine forwards or backwards. You know, a movie of planets orbiting the sun would look totally normal to the laws of physics if you ran it in reverse.
But obviously, that's not how we experience reality. For us, time is a one-way street, an arrow of time that flies from yesterday to tomorrow and never the other way around. Now, the most common explanation for this involves a concept you've probably heard of: entropy.
Think about it like this. A whole wine glass is a very ordered, specific thing. A shattered glass on the floor, that's disorder. And there are just way more ways for the glass to be in a million pieces than for it to be perfectly whole. So things naturally move toward disorder. This constant increase in universal messiness, this entropy, is the traditional reason given for why we remember the past, the ordered glass, but not the future, the shattered.
But here's the kicker. Is entropy really the cause of time's arrow, or is it just a symptom of something deeper? The theory we're digging into today argues that we've had it completely backwards this whole time.
And to see how this builds a totally different picture of reality, we need to introduce a new idea, a really crucial distinction: the difference between time with a capital T and time with a lowercase t.
So capital T time is not what your watch measures. Not at all. Think of it as the fundamental engine of reality itself. It's the deep-down machinery that allows for any change to happen, period. Lowercase t time, on the other hand, is just our human perspective. It's the ticking on our clocks, it's our memories, it's the changes we can see and measure.
Now, the author of this theory makes a pretty bold claim. They say that when physicists argue the laws are time-symmetric, they're missing something that's been hiding in plain sight the whole time. The arrow of time, they argue, is actually baked right into the math we use to describe the universe.
And you don't need to be a physicist to get this, I promise. These famous, fundamental equations all have something called a time derivative. All that means is it's the part of the math that measures change. And think about it. To measure change, you have to have a starting point and an ending point. The calculation demands a direction, from a t0 to a t1, from sooner to later. The forward arrow isn't some illusion. It's a mathematical necessity.
So the conclusion here is pretty radical. Entropy, the shattering glass, it doesn't create the arrow of time. It's just an obvious result of a much deeper, more fundamental, forward-moving engine, the machinery of capital T time.
Okay, so this naturally leads to a huge question. What in the world is this machinery of reality? Right, let's get into the speculative but absolutely fascinating part of this model.
This theory imagines that reality isn't made of a bunch of separate little bits or particles. No. Instead, it's one single, unified, continuous fabric. A four-dimensional object that has the three dimensions of space we all know, plus one special dimension of capital T time.
Now, in a model like this, does a single frozen moment in time, like, one frame of a movie, even make any sense? And the answer is no. A single snapshot, a single point, tells you nothing about change. If you see one picture of a ball, is it moving up or down? How fast is it going? You can't possibly know. For change to be a real thing, reality needs duration. It needs a connection between at least 2 points in time. So how does change happen in this model? Well, imagine our three-dimensional space is just constantly sliding along that fourth time dimension. It's a continuous process where the configuration that was the future a split second ago becomes the present right now. The configuration that was the present becomes the immediate past. And the old past, it just ceases to exist. It's gone.
All right, so this gives us some new vocabulary to play with. Space-time, with a capital S and a capital T, is the whole shebang, the unified fabric of reality itself. And the time interval? That's the special fourth dimension that makes change possible, the one our space is sliding along.
So, what does all of this mean for us, for you and me, and how we see the world?
And here is the really big takeaway. Everything we call time, lowercase t time, our clocks, our feeling of flow, our memories, even entropy, they are all just emergent properties. They're like shadows being cast on a wall by the true, hidden, underlying machinery of capital T time. We aren't measuring the engine itself, we're just measuring the effects of it running.
You know, the physicist Ernst Mach said something like this a long time ago. He put it perfectly. We think our clocks measure time, but they don't. They measure change, the movement of their hands, the vibrations of a crystal. And from watching all these different changes, we invent this abstract idea we call time. To put it another way, we're measuring the wake of the boat, not the boat itself.
So the ultimate takeaway here is pretty profound. We might be fundamentally mistaking our perspective for reality. Our human time is a product created by the machinery's behavior, and our science, our experiments, are incredibly powerful tools. They all exist inside this fabric. They are brilliant at refining our view of the shadows on the wall, but they might not be able to show us the machine that's actually casting them.
And that leaves us with a huge, lingering question. If all of our tools, all of our science are products of the very system we're trying to study, are we just stuck inside our own perspective? Can we ever truly glimpse the machinery of reality? Or are we destined to only ever study its effects? That's a question that sits right on the border of science and philosophy. Thanks for joining me on The Explainer.